If you speak the truth, have a foot in the stirrup.
Hello, and welcome to another installment of the Sea Realm Podcast. I'm your host, KMO, and this is episode number 582, Convolve and Attend, with Roger Craig. Prepared for release onto the World Wide Web on Sunday, July 17th, 2022. All right, you've probably heard that the world is being eaten by software. That software in the past was written by human beings. These days it's written by human beings but trained on very large data sets. And this episode of the podcast, I'm going to have to apologize in advance to a segment of the audience. This is going to be tough going, particularly at first. I talked to Roger Allen Craig about language models and text-to-image generating AIs and all manner of, well, not all manner, lots of different kinds of algorithms which are trained rather than explicitly hand-coded. And toward the end, we talk, in some practical terms about how these things are changing our lives. But for the first half hour or so, it's going to be pretty technical. If you get bogged down and, if recourse to mathematical explanations isn't helping, then I'd say go ahead and jump ahead to about the 1 hour mark, and you'll find some easily digestible conversation. I'll let you know right up front, I've been reading about this topic and listening to people talk about this topic for a little while now, and when Roger, busts out the math talk and offers up phrases like a vector of real value numbers, I'm as lost as you are. So again, let me encourage you to stick with it. And if you feel that you are completely lost and, a re-listen isn't going to help, then do jump ahead toward the end of the podcast. There is some very accessible, non-technical conversation. But to introduce the guest, Roger Allen Craig is an American game show contestant and computer scientist. He held the record for highest single-day winnings on the quiz show Jepordy from September 14th, 2010 to April 9th, 2019. In 2011, Roger returned to win the Jeopardy! Tournament of Champions. So I kind of do Roger a disservice in that, if he's really good at Jeopardy! He's got a lot of information right at the tip of his brain about a variety of topics. But I have asked him to try to translate a very technical topic for a general audience, and that is a tall order. At a couple points, you'll hear that I have inserted some AI-generated text-to-speech, basically just unpacking or, providing some definitions for things that Roger mentions in passing. And I created these. There, you'll notice there are a couple different voices. This is at readloud.net. So this is just browser-based stuff that you can type in some text and hit a button, and it'll read your text for you in a variety of voices. So I'll play the conversation for you here in just a moment. I just want to let you know that I'm including some informal chit-chat before the introduction, and we're talking about how we have to be careful about saying the word Alexa out loud, because she's always listening and will often respond when you're trying to have a conversation with somebody, and you didn't really mean to invoke her, you just meant to reference her, and she's not smart enough yet to know the difference. So that's Mrs. A, or Ms. A. All right, here is the conversation with Roger Craig, and thanks to Elliot for making this introduction. All right, here we go.
You're listening to the Sea Realm Podcast. C stands for consciousness.
A buddy of mine started saying Mrs. A when we want to talk about Mrs. A.
Yeah, you think she's married?
Oh, or Miss A. I mean, that was what my friend said, and I just went with that. I didn't even think of the marital status. Yeah. Madam A, whatever, Mademoiselle.
I'm sure lots of people have at least a low-level crush on Ms. A.
Well, that plays, without jumping too far ahead, the guy with Lambda, there is this whole, trend now of people developing these I don't know if it's parasocial, that's more with celebrities, but these relationships with these devices that they're communicating with. Yeah.
Well, I'm going to go back to the bio that you prepared and let everybody know that I'm talking with Roger Craig, who is the principal at Signal Alpha, a machine learning consultancy working primarily in the field of natural language processing. He's worked on machine learning projects in the domains of molecular biology, protein-protein interaction prediction, biodefense, finance, insurance, natural foods, communication surveillance, that's a little spooky sounding, aviation, electronic medical records, and among other things, you have been on Jeopardy, and you were likely most well known for holding the single-day winnings record from 2010 to 2019, winning the Jeopardy Tournament of Champions, using NLP, that's natural language processing, not neuro-linguistic programming, to prepare for the show.
John Bandler didn't help me, no.
All right, so I guess that's a great place to start. How did you use NLP, again, natural language processing, to help you prepare to participate on Jeopardy or compete on Jeopardy?
Yeah, so I use that mostly to, let's say, bring order to chaos. And what I mean by that is you have a large corpus of data. There's actually a website called the Jeopardy Archive that these volunteers transcribe all the questions on the show every night. And so I basically downloaded the website. This was all back in like 2007, 2008. And essentially I wanted to quantify what that corpus was like. You know, what percentage of the questions were on Shakespeare, what percentage on presidents, what percentage on chemistry, whatever it was. And then sample from those. I made like a little web tool and just answered questions and saw if I was right or wrong. And so then I got self-knowledge. So this tied into like what, you know, the quantified self movement of tracking, well, first getting a static snapshot of how well I was doing in each of those categories. And then, you know, deciding which ones to tackle, and then seeing if I was improving over time. And so that was the main way. So the actual, you know, there was no like chat bot or anything. It was really more about what would be termed like text clustering and topic modeling, and just taking a large, you know, body of documents, a corpus that you never have time to read through. And you also don't want to manually label, or maybe you manually label a small percentage, and then you want to understand what it's actually talking about, you know. So, you know, and this is a very useful concept and comes up again and again and again, because many people, you know, we're much better at it now. And a lot of these NLP models are much more useful in doing this, labeling all this unlabeled data in various ways in terms of topics.
Did you say you were doing this back in 2007?
Yeah, that's right.
So it's my understanding that neural networks weren't good for much back in 2007.
Yeah, that's a great point. This didn't involve any neural networks at all.
Okay.
So this is really, just think of it as, you know, okay, to get technical, it's really just counting. It was tokenizing the documents. These were questions and categories that are on the game show Jeopardy, and then counting the appearance of the words. And then, you know, so this does segue into what we want to talk about. But so the first thing you can do is, say you have 250,000 questions, just see how many unique words you have in there, right? And you might have like 110,000 unique words, or, you know, something along those lines. So one way to
language is large.
Yes, yes. Because the English language is large, this is sort of the old school NLP methods. This almost is akin to information retrieval. You can then represent every document as a vector of length 110,000. It wasn't 100,000. You can actually you cap it off. Like, you're going to have a long tail of very infrequent terms, or terms that appear only once or twice or 3 times. You don't care about those as much. You care about the more frequent terms. not like the head terms. Those would be the, of, and, all the stop words, let's say, in natural language processing in the past. So these would be more the terms like president, vice, cabinet, White House, Capitol, and those terms would tend to co-occur. And, now you have your government or history cluster. So I do not use neural networks at all. Is the short answer. Sorry.
You didn't then.
No.
You
No.
are working with them these days.
Yes.
Okay.
Yes.
So
yeah, everybody is pretty much.
if you're not, you're
Yeah.
playing the wrong game. For your information and for the edification of the listeners, many of whom I think already know this, I went to grad school for philosophy in the 90s, and my specialty was recent Anglo-American philosophy with emphasis in philosophy of science and philosophy of mind. And, the philosophy of mind in the recent Anglo-American tradition is, it's analytical. It's basically synonymous with AI. Just, it's a natural language discussion of, how you structure a mind and how a mind would interact with the world, that sort of thing, just without any programming. Basically, you're not building anything that does anything. You're just, modeling stuff in an abstract space. And at the time, there were champions of neural networks, but they were basically just talking up the potential of neural networks, because this is, 2000, or not 2000 anything. This is 1994, 1995. I mean, nothing really had been built that could approach the utility of what at the time was called good old-fashioned AI, which is just human-coded, explicitly structured, programming. But there was an idea that you might be able to train neural nets, and there was talk of weighting certain connections and, reinforcing particular outputs to over time shape this thing so that it could, in theory, someday be as good as, if not better than, stuff that's just explicitly hand coded. But, when I was in grad school, that was still just speculative. And I had been out of grad school for, more than a decade, like decade and a half, by the time 2012 rolled around. And that's the year, looking back, that it seems like a variety of, well-known papers and winners of contests and, university programs really started to get things rolling. And I think with like a long-standing problem in artificial intelligence and robotics is computer vision. And I think there was a lot of breakthroughs in computer vision that year, which then spilled out and had, effects in other fields as well, including natural language processing. And usually the name to reference, for this period of time is Geoffrey Hinton and his team, I think in Toronto. So, from that moment on, it seemed like suddenly neural networks and algorithms that you train rather than program and train on, large data sets, suddenly that stopped being, in the realm of speculation and of interest only to people in AI or philosophy of mind, and suddenly, became of interest to people who wanted to make money. The last decade has basically been the implementation phase of that, that sort of revolutionary period where significant breakthroughs were made. So I'm speaking in very general terms. Let me turn it over to you and ask you to, flesh out what I've just spoken of there with some more specifics.
Yeah, that's a great synopsis. And I would say there were a few smaller wins in neural networks prior to then. Going back to like the 80s, you had Jan LeCun doing stuff with digits, right? Like the classic MNIST data set, which is the handwritten numerals that would appear on checks or on mailed envelopes, right? And then also in the 90s, these were very narrow. It's actually interesting now. I don't know if anyone's ever gone back. You had a group at CMU that actually had a self-driving car in the 90s with neural networks, and they drove it on the highways around Pittsburgh, I believe.
Really? They were on the roads with human drivers, not just on a track.
Yeah, I'm pretty sure, it's been I haven't read about that recently, but I do know they did drive it. And I'm sure it was on a sunny day with perfectly marked lanes. There were probably no other cars around.
Gotcha.
It wasn't driving in Midtown Manhattan and 5 p.m. on a Friday through Times
Right.
Square. You know what I mean? Like
Right.
that's gonna take a while. And also when it's raining and snow's on the ground, and so yeah, there were some wins there. And then, but during that period of time, it is true that neural networks were sort of in their own little AI winter in a way, or they weren't the hot thing. And I'd also like to speak a little bit to that. I think there's interesting reasons for that. One is that most of this work was being done in academia. I'm sure industry was working on it, but they weren't really advancing it much. And so as the culture of academia, it's all about publish or perish. And it's also about showing how smart you are. It's only recently that a lot of these advances, it's about doing better on a problem versus the actual brilliance of the method that you have come up with, right? So there were other methods that frankly allowed computer scientists and these mathematicians to use more sophisticated or interesting mathematics. And that's what they like doing. So it's like what you say with the handcrafted system. A big trend in all of this is that human hubris, we would like to design some system that we've put a lot of intelligent thought into, and we have all this learning through human history and encode that into the system. Or on the other side, you just take a bunch of data and you do logistic regression on it, and you transform the data in some way, and you get something that outcompetes anything the most brilliant people in the world can come up with, right? That can be interesting or fascinating. It could be depressing, depending on your point of view, and it has huge consequences for the future when you think about, who has the large sets of data, who has the compute power, to the money to do these things. So getting to 2012, yes, AlexNet, which is named after, I believe, a grad student of Hinton's by the name of Alex, and I'm blanking on his full name, devises a convolutional neural network to do image classification, right? And the state-of-the-art existing methods before that were primarily not using neural networks, and we're using algorithms based on edge detection and then segmenting the images. And I should wrap all of this with, I'm not an expert on computer vision. This is my high-level understanding. And
I'll extend your caveat and say that you had no notion whatsoever that I was going to quiz you on the history. You were prepared to talk about the present day. So this is all off the cuff.
Yeah, and I'm willing to discuss, like I said, anything and everything. So AlexNet was a convolutional neural network. So
let me have you pause there. What is a convolutional neural network?
A convolutional neural network is most usually two-dimension convolutions. So what you do is you take in an image. Typically, you would, let's say, make it square. It doesn't have to be square, but that simplifies everything. And then the layers of the neural network, you are essentially shrinking the square through convolutions. And so what that means is you look at all of the elements in the matrix, like you've converted the image into a matrix or a tensor. Okay, without getting into all the nitty-gritty details, what essentially is you take a larger image and you represent it in the matrix. Like the first thing you would feed in are, say, the RGB values or the grayscale values of the pixels in that image, okay? And then you shrink it down smaller and smaller. Each layer in the neural network will have a smaller square. So that sort of encodes it, right? So you're getting a smaller representation of the image using less information, but you've captured the essential parts of the image. And then once you have that, then you can take that representation and do classification on it, okay? so you get this representation. Think of the representation as a vector of real valued numbers, right? So if you started with an image that was, say, 1,000 by 1,000 pixels, it has 1,000,000 pixels in it. And let's say it's grayscale. Each of those is 0 to 255, right? And, the image that you feed in is a vector of length 1,000,000. Well, doing these convolutions, you get it down to a much smaller vector that might only be like a few hundred or 1,000 numbers. And so now you've basically put this image and compressed it into like 1,000 dimensional space, or a 300 dimensional space, whatever it is. And you can keep going smaller and smaller. You'll lose information each time, but you're also like generalizing, right? So you're capturing the essence of the image. Then what you can do, you can train the model. So when you train it, those convolutions of how to shrink it, those are being learned during the training process of the best way to train them, essentially. One way to train them is by using what's called an autoencoder. So you can convolve and you shrink it down. Well, then you can do the opposite, and you can have convolutions that build it back up to 1,000 by 1,000, let's say. And so Hinton, a lot of the early stuff, well, let's say early, like 10 to 20 years, and even going back to the 90s or 80s, the concept of an autoencoder. What is an autoencoder? An autoencoder is where you have the neural network have as input the image, and then you have the output the same exact image. And you actually have it learn to encode its own image. And it won't be perfect because you're losing that information. You're shrinking it down to a much smaller size of a vector, right? And then you're learning how to reconstruct the original image. And then, initially the network is randomized, initialized randomly with all the weights, right? So you get like almost random noise out the first time you do it. And then you compare it, and then using like, back propagation and all these methods, you adjust the weights until you converge, or let's say minimize your training loss to something that is, the output image most closely resembles the input image. And then so what that does is when you train that, you can actually then remove the bottom half of that, because you have the encoding at the top and then you have the decoding at the bottom. And so the thing right there in the middle, that is your representation. So let me just pause there for a second.
Okay. First, I'll say, when you start listening to people talking about AI, you'll discover that they use language rather differently than people who are just speaking conversationally out in the world. For example, they will use the word compute as a noun.
Oh, yes. Compute.
Right.
So what is, okay.
I take it to be just short for computing power, or, processing.
Yeah, that's probably what it is. It's just saving 2 or 3 syllables. Yeah. Compute.
Typically, the only time people in normal conversation use any form of the word convolve is as an adjective to say that, dude, that's convoluted, which is to say it's poorly structured. But,
Yes.
Convolve is a verb. It means to entwine. And convolute, in AI talk, these don't mean what they mean out in, the larger world. So you've been talking about, the process of convoluting. I guess I don't want to spend a whole bunch of time on it, but I think maybe it needs just like another minute. When you invoke that concept, what's just a conversational sort of level shorthand? What is involved when you're talking about a convolution?
Yeah, that's a great question. And yeah, one of the definitions is convoluted is something that's like completely hard to understand. Yeah.
Right.
So, just looking up a definition here in Wikipedia, they have it as a mathematical operation on 2 functions that produces a third function. So that's one definition. But this is what I'm saying. I'm not an expert on computer vision. Mm-hmm. My understanding of convolutions is you typically, let's just stick with 2D matrices. And then you have some function that operates on the cells in that matrix to produce a new matrix. And the new matrix can be the same size, it can be smaller, or it can be bigger. So maybe a more easily comprehended example would be like Photoshop and GIMP, right? They have convolutions. Those image filters, when you do blur or sharpen or edge detection, those are actually convolutions where you look at the values of the pixels, and it can even have like a 3x3 window, and you just go over all the little 3x3 windows in the whole image, and you multiply those values by your convolutional kernel, and you end up with new values. And for the purpose of blurring and edge detection and sharpening, that will be the same size, because you're just going to blur the image, or you will sharpen it or do edge detection. And that's what we're talking about with convolution. So it's a way to just think of it as a way to take a matrix of numbers and then map it into a new matrix of numbers, where you're multiplying at the most basic level, multiplying them and then summing them in some way to then get new numbers. Yeah.
For me, what's big in the news is programs that are, text to image generation programs like DALL-E 2. Yes. And now, DALL-E 2 is the big one. It's the one I don't have access to, so I have to content myself with things like Wombo Dream and Midjourney. But these are amazing devices where you can, you just put in a text prompt, show me a teddy bear walking through Times Square. And DALL-E 2 is astounding. I mean, it gives you these photorealistic images of a teddy bear walking through Times Square or riding a skateboard or whatever. The other things that I have access to, they're not quite that good, but still they do amazing things in terms of, you give a description of what you want. It shows you something that isn't anything like what you visualize, but it's still amazing because there's so much like simulated brushstrokes and play of light and, interesting compositional things and textures that come to the fore. Stuff that would take me as, a graphic artist just doing stuff by hand, hours and hours and hours. And maybe I couldn't do it at all. Maybe there are techniques there that I just don't know. And it does it in a few seconds. And yet at the same time, it's incredibly frustrating because it's nothing like what I wanted. When I had an image in mind and then I'm coming up with a sentence to describe this image, what the computer comes up with is nothing like what I had in mind. But it's very interesting in its own right. But what it's doing there is it's basically starting with a random like static field. It's basically just a screen of gray with a few blotches of darker gray in it. And it's running this convolutional process on that over and over again. And each time it's transforming the image, it's looking for familiar patterns which are statistically correlated with words in your prompt. Each time it refreshes, you can see it's a little bit closer to the final product. And sometimes what'll happen is you'll have what looks like the perfect final image and you're like, okay, stop. But there is no stop command. And it just keeps going. And it actually overwrites and obliterates this beautiful mid-series stage. But it is running, a sort of convolution, as you've described, to create these. At least like Wombo Dream and Midjourney, the ones that I'm, that I have access to and can observe and work with, that seems to be how they're doing it. So just as an illustration, I think, to, what you've been describing.
Yeah, I do, not to get too technical, I do think I think you're absolutely right. I think it's slightly different than a convolution to reconstruct the image. But yeah, typically these are like diffusion kernels, and they trained it by adding noise to the images and the training data. And then they progressively add the noise, and then they flip that and they train a neural network to take noisy images and make them less noisy. What it does is it takes your text input and it generates a representation of that. And then it uses that representation of the text input to guide the removal of the noise. And yeah, you're right. It starts with random noise, typically on a square canvas. And then it starts to generate the image that will match or be close to the representation of the text, because it was trained this is really interesting because it's text to images. So you have representations of the text, and then you have representations of the image, and you try to align them during the training process of these systems. And so when you put in Kermit the Frog or teddy bear skateboarding in Times Square, it has a representation of that because it's been trained on images that have teddy bears, have Times Square, and have skateboards. Maybe none of them had all three of those, but it's able to compose them. And then, and then the new ones from Google, like Imagine, which is a brilliant name. I'm surprised no one's ever used that name before. Image Gen, Imagine, whatever it is. And then Party. Yeah, I'm like, you just add an N to the word image, and it's like Image Gen, Imagine. Like, oh my gosh, like, so there are...
somebody got a nice bonus for that.
Yeah, there are, 6-letter portmanteaus out there that are, have been unexplored, and they're still good. So
I'm sure there are neural network algorithms exploring that space, looking for interesting combinations.
Oh yeah. And then I was actually lucky enough to get DALL-E 2 access a few weeks ago.
I'm jealous.
So I've played with that most days, and you really overdose on it in the beginning. And it's just unbelievable. You can, it doesn't do text, right? Another one, I would like to try Midjourney. I haven't looked into that at all. There's also like Disco Diffusion, and there's some collab notebooks where you can run those. And then interestingly enough, there's like models, some of these models are coming out of Russia, right? Where you actually use Cyrillic text to generate the image. And if you put English in, it actually just Google translates it or whatever to the Russian and then generates the images. Very, very akin to using these convolutions to reconstruct an image.
So let's push on. I think you may have mentioned just in passing adversarial networks or adversarial, what's the word?
Yeah, GANs, Generative Adversarial Networks.
There you go, right. What are those?
So GANs, it's GAN, Generative Adversarial Network. And so it's sort of the combination of two things. You have essentially a generator which will generate images. These, we were just talking about text to image. These typically, the original formulation, there's no text involved at all. Okay. So instead, the first GANs, of course, I believe were generating faces, right? Human faces. And that's where you see like style GAN. And there's some really amazing, this person does not exist.com, that type of stuff.
Which generates photorealistic, fool the eye images of human beings that if somebody showed you this image and said, yeah, I ran into this guy at the mall, you wouldn't question it. You wouldn't say, I don't think that's a real person. I mean, they just look like photographs. Yeah. But they're not any particular person. They're just, these not randomly, but they're computer generated combinations of features and that, no living human being actually has this particular combination of features, most likely.
Yeah, and you wonder how many LinkedIn profiles and Facebook and Twitter these headshots are really, this person does not exist screen grabs. And so what the generator does is it learns how to generate images in specifically faces, let's say, right? And it learns how to generate faces. Then you have another part of the system. We call that the discriminator. And what that does is it just has to make a binary decision. It has to decide, is this a real image or was this image generated by the generator? Okay. So it's basically trying to see like, is this a real photograph of a human or was this created by the generator? And so that's where the adversarial aspect comes in. So it almost becomes like a game and they're competing against each other. And the generator is trying to fool the discriminator into not being able to tell the two apart. And the discriminator is trying to detect the fake images as best it can. And then, so, they essentially like play this game and both get better. And what happens is the generator ends up getting really good at fooling the discriminator. And then that's how you get the photorealistic. effects. And when they first came out, they would have these strange artifacts where like everybody would have two different colored eyes, or they'd be, wearing an earring on one ear, but then their other ear, or their ears were shaped differently. And then, they've done a lot of work and like fixed a lot of those issues. And it's like, you used to be able to like, if you knew what you were looking for, like look at an image and pretty easily tell if it was a GAN. But now they're getting so good. Yeah, it's scary.
We've been talking about imagery, I think mostly because I'm a visual artist and I'm interested in that sort of thing. But I know that your day-to-day work is with natural language. So what's a good segue to take what we've talked about so far and port that over to the topic of natural language processing?
Sure. I think a great segue would be, we were just talking about GANs, and we talked about the discriminator. Depending on what we want to talk about, one key thing I always like to talk about at a high level is the difference between discriminative models and generative models. So discriminative models are ones that have to discriminate. That is, they have to make a decision, usually classification, let's say. They have to decide, like, is this a fake image of a face, or is it a real image of a face? And it could also be like, is this movie review positive or is it negative, right? The financial institution, do we give a loan to this person or not? Is this person going to vote for candidate X or not? Is this person going to click on this ad or not? So
predicting human behavior is definitely a big commercial aspect of all of this stuff.
Yes, yes.
Shoshona Zuboff wrote a big, long book about it called The Age of Surveillance Capitalism, talking about how the big tech companies are hoovering up our data exhaust that we create all day, every day with our devices, building models about us that are predictive as to our tastes, our purchasing decisions, our voting decisions, and then their marketing departments figure out who is the best customer to sell these models to and these predictive products. So this is the commercial application, which is not new. I mean, it's developed. It's pretty mature at this point. I mean, it'll probably get much more sophisticated as time goes on, but it's not like nascent at this point. This is an existing industry.
Yeah, exactly. It's huge, and we only see glimpses of it too, of what is occurring, right? And the thing I just wanted to wrap up there is discriminative models were like, that's what everybody was doing in the beginning, and it's still huge, like you just said. But then you also have generative models, and these are models that essentially aren't making a decision about the input. They instead are learning from all the training data how to generate new instances of that training data. It's like never before seen. And that can be text, it could be images, like in the case of DALL-E 2 or Imagine and Party and Midjourney and all the rest. Or it can be text, most famously with like GPT-3, or recently in the news, the Lambda, right? Lambda, the dialogue application out of Google. We could also take a step back. You mentioned philosophy of the mind. Let's just think about our own minds, right? For the purpose of images, we have a discriminator. We look at something, we know if it's a bird or not, right? And if it's flying in the air, it's probably a bird, but just so it's not a bat or a flying squirrel or a dragonfly. And then we have exceptions to these rules, like we see a kiwi or a penguin or whatever. But then we have generators inside our head. Like if we want to sit down and draw a bird, we can draw a bird. Like a 3-year-old or toddler or whatever can sit down with a crayon and draw a bird. Same with text, right? So if something says something to us, we process it and we're like, is that a question? Is it a command? Is it a salutation, a valediction? What are they saying to us, right? Is it expletives? I mean, like whatever situation you're in. And then obviously we have generators we can speak. So I just wanted to contrast that, sort of when we think about even learning a new language, you have text and you also have audio and sound, but we have recognition first, and then we have production second, typically. A baby has to listen to human language before they start speaking it. And then another thing I would say is to segue into natural language processing. In machine learning in general, you typically have three things for most machine learning. And that is, you have data, and your data is labeled or unlabeled, and then you have representations of that data, and then you have a learning algorithm. And depending on what you want to do. And so a key part of that are these representations that are in the middle. Your data can be any modality, text, images, labeled or unlabeled. And then your learning algorithm could be decision trees or linear regression, it could be neural networks. And the neural networks can also generate the representations that you then take and use in something else. So that's a side note I wanted to say too. With all these pre-trained language models, they have these internal representations of the text. You can actually then take those out or export them and use them in a completely different system that doesn't involve neural networks. So for instance, with like Bert and Roberta, or these sort of encoder natural language processing networks, you feed in text, you get representations, and then you can put those into some system, like say a semantic similarity search, and this will improve the search, hopefully, versus other methods.
So I'm not familiar with Bert and Roberta. What are those?
So Bert and Roberta, well, let's just start with Bert first. That came out in 2018, and it was a year after the first Transformer paper in 2017.
Uh-oh.
And it was a way to encode, yeah, and it was, okay, sorry. And it's a neural network model that you feed in text up to a few thousand characters, or tokens, let's say, and then you get out of it, you get a representation that is a 768 dimensional vector. And then with that vector, you can then use that to put another layer there for, say, classification, right? And classify the sentence or piece of text as positive or negative, right? Or neutral sentiment. You can also use those representations. You could put in two different sentences, and you could say, are these sentences similar, right? Are they contradictory, or is there like entailment? Bert was as AlexNet was in 2012 for images, Bert was that for NLP in 2018. I think that's a fair statement to say, because it then broke all the previous state-of-the-art metrics on various data sets.
So you've mentioned the word transformer in passing. It needs a definition.
Yes.
And that's not an easy one to define, from my experience.
Yeah. so the transformer, how to say it? Okay, so let's motivate it. Before the transformer, most text data, the use of text data in neural networks was used recurrent neural networks and things like long short-term memory, which was created by Jürgen Schmidhuber. We need to give him credit. And these were neural networks where they operated on one token at a time, and they would the structure of the network would encode how it was understanding the text. And it would be like very long, and like once you got to the end of text, you would sometimes lose the thread of what was in the beginning. This is a big simplification. So transformers, what they did when they came out with them in 2017 was they said, you know what, let's just have the text look at the text, the text that we're interested in, let's have it look at all the other text in the same piece of text at the same time. So essentially you get like a big matrix. And so you would tokenize the text. We can talk about that. But let's say we just split it on white space for now. They actually do something different, but let's just say, or we split it into characters. But I think white space is better for English speakers. And we split into text and by white space, and then we get a matrix. So we have it look at it all at the same time. And then we introduce the concept of, say, attention. And so attention is like, where should it be focusing, okay, in this matrix? One thing I would like to back up and say is that in the computer vision world, they were using those convolutional networks, and then they introduced the concept of attention. So I'm pretty sure attention was definitely introduced in computer vision before text. And what that did in vision was it allowed them to decide which pixels to focus on. And you can think of the biological analogy of this as being the fovea of our eye. We can see like a whole visual field, but it's only
What part is the fovea?
Oh, I'm sorry. The fovea is the part of the retina that is the rods and cones are at their most dense. Okay. And if you think of the bandwidth of the optic nerve coming out of the back of the eyeball, like the fovea is where almost all the information, like the vast majority of the information, is coming from this small part of the eyeball that's right in the back center. Like typically when we look straight ahead at whatever's in focus, it's almost in the middle of our visual field, right? It's not off to the sides. That's our peripheral vision, and that's usually much blurrier. But we can look to the side and it becomes sharper. So the thinking is that, you don't have to look at all parts of the image. You have to look at the interesting parts of the image. And as human beings, our eyes flit around, whether we're reading or looking at an image or just walking around in everyday life. You don't just keep staring straight ahead. Your eyeballs move around and you take in parts of the scene. And if things aren't changing, you tend to move your eyes, right? But if you're watching television or a movie, you just stare at the TV like forever, So I just wanted to point that out. So attention was a way to encode in the neural network which parts of the data to focus on. And so when you think about it with text, if you have a sentence, we actually don't focus on the ands and a's and thes and ofs. We focus on the least probable words that have the highest semantic input, right? So if I say, the World Series, the World Series was won by the New York Yankees, and you just listen to that, you're not really paying attention to the word the or was. You hear World Series won and New York Yankees. That's what we're attending to. And coming back to the transformer, it has multiple layers, right? So it can have, Bert had 12 layers, right? And so each layer is a different attention layer of transforming that initial text, which we've encoded, and then we learn a new representation of the text, and we do that 12 times in a row. And so in the beginning, what you find out is in the beginning, the text, all it does usually in the beginning, it attends to the neighboring tokens and, just points, because it has these positional encodings. We've also told it where all the text is. This is the first word, this is the second word, this is the third word. And so 3 mostly attends to 2 and 4, and 4 mostly attends to 3 and 5. And it will have, 3 will have some attention to the 9th in the beginning, but it will be less, right? And then as you train this neural network, the BERT, for instance, you will then see if you pass in that sentence, the World Series was won by the New York Yankees, World and Series will start to attend to each other more strongly because they go together. And, if you pass in billions and trillions of sentences, and New York Yankees will attend to each other. And then once you get down to the lower levels, the 12th layer, you'll actually see New York Yankees attending to World Series, having a long range correlation. So that's a key thing too. In machine learning, you devise these systems. It was always relatively easy to capture short range correlations over a sequence, right? That's you have a sliding window and you can just look at your nearest neighbors, the day today, there's today and we have yesterday and we have tomorrow, but it's harder to capture a correlation between today and a month ago or 2 years ago or a month in the future, that type of thing. The key thing was to have the whole text you feed in be able to attend to all the other text at the exact same time. And so that way you can capture a long range correlation from the end to the complete beginning or anywhere else in the string.
Let me have you pause, and if you can,
yeah.
give me a definition of transformer that involves 20 words or less.
Okay, I'm sorry. Yeah, if I'm a little long-winded there. 20 words or less. So it's almost like a haiku. The transformer is a neural network that uses attention such that, I shouldn't say things like such that, then strike that.
I'm not counting words.
Okay. But the neural network, the transformer is a neural network that uses attention where any element in the sequence can control or influence, at first attend to another element of the sequence and also help influence its representation. And so they influence one another. Let me just back up. Some of these things can be viewed as black boxes or gray boxes.
A black box tester is unaware of the internal structure of the application to be tested, while a white box tester has access to the internal structure of the application. A gray box tester partially knows the internal structure, which includes access to the documentation of internal data structures as well as the algorithms used. Gray box testers require both high-level and detailed documents describing the application, which they collect in order to define test cases.
I should also mention, I'm not researching these. I am more a practitioner and user of them. So they are incredibly complex. What I would say is what it really gives you is you get better representations, and you can have this correlation between the text, and it captures that better than any existing methods before it. When you feed in that text, you have a certain context, like the World Series was won by the New York Yankees. And so that becomes a context, and it can control the representation. Anyway, now I went way over 20 words. I'm sorry. But, my point too is that these are very hard to understand, interrogating these systems. And then these models end up having 1 billion parameters. No one really knows how they're actually working. They just work. And then you can interrogate them and see certain things. And, then you get into aspects there of explainable AI and interpretable AI. One thing I want to mention too, backing up, is let's talk about NLP just real quick before neural networks. In traditional NLP, you would take in text, you would pre-process the text, you would tokenize the text. Then you would do things like you would detect the parts of speech, right? And then you would do named entity recognition, and you would do all these different layers. And then what they've done when interrogating something like Bert is they actually see these 12 layers sort of relearning those exact steps that the humans had done in the 80s and 90s and early 2000s. And I think that's really interesting.
Does the name Connor Leahy mean anything to you?
Connor Leahy? No.
Okay. I listened to a couple interviews with him just yesterday, and I can't, recite his CV from memory, but he was talking about a lot of the same topics we're talking about, but he was talking about how a lot of the people who become really good at manipulating or at providing input for things like image generators or something like GPT-3 to generate new text. He calls them prompt engineers, and he says that the prompt engineers are typically not particularly technical people. They might write some code, but they're not the people developing these systems. They're the people who have been brought in who are just very creative and smart and curious and are willing to spend some time interacting with these systems. And they get really, really good at learning, what words to feed into the system in order to get out an output, which is really satisfying. And he was talking about how, after Deep Blue beat Garry Kasparov, the Garry Kasparov, chess grandmaster, world champion, he was, if you could beat Garry Kasparov, At one time, you were the best chess-playing entity in the world. Well, then Deep Blue came along and beat him. And there was a period after that where a grandmaster playing in conjunction with a chess program together could beat the best chess-playing programs. And Garry Kasparov called those pairings centaurs. And there was a period where centaurs would beat the best chess-playing algorithms, and then that period ended, and now the best chess-playing entities on the program don't have any human components at all. There is no use for chess grandmasters anymore. And Connor was talking about how we've entered this period where if you want really satisfying computer-generated novels, say, or, computer-generated imagery, you're still going to get much better results with a creative human artist or writer interacting with a system like this and sort of editing it, giving it prompts, taking its output, keeping what's good, cutting what's bad, pasting it all together, and then, maybe rewriting it. We're in this period where the creative centaur is still outperforming the algorithmic artist. But, like the chess-playing centaurs, this is a finite period. There's going to come a time when humans in the loop are just, they're just an impediment. They're not helping things at all. I wonder if this is much more high level and, sort of conversational than what you've been talking about so far. But I'd kind of like to switch to that level for the end of our portion here on the Free C-Realm podcast. What do you see, in the work that you're doing, where there are possibilities for people who don't write code, people who don't have engineering degrees, but, who have just general intelligence to interact with some sort of algorithm or, some sort of, neural network or some product of the work that you do to create something new and exciting?
Yeah, I think the best way to approach that too is with like DALL-E 2, like with the text to image generation. I know that Connor, by the way, I looked him up, and yeah, he's one of the principals at Eleuther AI, and I've actually watched the interview with him, but I forgot the name.
Yeah.
I apologize, Connor.
No, you listen to a lot of interviews, and there's a lot of names.
Yeah. One thing too about with chess, I would dispute the chess centaur speculation that a human plus a computer cannot beat a computer. So are we saying that if you had Magnus Carlsen and AlphaZero from DeepMind, right, play AlphaZero, Magnus Carlsen would add 0 to that? Is that what we're saying? That they would just tie all their, over the long run, they would have like 50% equity on win share,
So I am just reporting this observation from Garry Kasparov. This is not a statement that I defend or have any investment in. So it's not a debate I would be interested in entering into.
Okay, I take that back. Yeah, Connor didn't put that forward. Garry Kasparov did. Okay, right. So Garry Kasparov is extraordinarily knowledgeable about chess and very knowledgeable about chess playing computers. That's an understatement. Interestingly, I met him. Well, he walked right by me. I went to one of his matches in New York in 2003 against Deep Junior, which is where they ran it on a laptop and he played it, which was different than Deep Blue.
The final game of the epic man versus machine match between Garry Kasparov and Deep Junior ended in a 3-3 tie.
As for prompt engineering, I would say that DALL-E 2, Midjourney, all of these coming out, that's exactly what's needed right now, is these exploration of prompts. So there are like subreddits and Discord servers specifically dedicated to DALL-E 2 and probably all the other ones, where people share their best prompts and what pieces of text you need to put in to get the best image results you want. So for instance, if you put in like space type scenes of a meteorite hitting, Mars, if you put courtesy of NASA / ESA, the European Space Agency, you get much better results. Like it looks cooler to the human eye.
Mm-hmm.
And
or you can end your prompt with Unreal Engine.
yes,
Yeah.
Unreal Engine is great, especially
Yeah.
for digital art.
Mm-hmm.
And you do digital art, trending on ArtStation.
Or you can end your prompt with a description of the camera lens and, aperture and, the f-stop basically. And
Yes.
you'll get an image that looks like it was photographed in a particular way with particular equipment. It's
it's pretty wild because you can, and then even more simply just put 35 millimeter, or you put 50 millimeter or 18 millimeter,
Mm-hmm.
like for the focal length, and it changes the image. And you can put the model of the camera even. I've done prompts with DALL-E 2 where it's like Fuji Pro, yada, yada, whatever Fuji Pro camera. I have a Nikon myself. And in the sharing of the prompts, the thing is that what's interesting to me is you kind of almost have to arrive at it by dumb luck, unless you're able to interrogate the training data for these systems. And some of the open source text-to-image algorithms, they're being trained on the Laion data set. That's like LAION. And that was, I think, 500 million images. And now it's like 4 billion. And they actually have a website you can go to and just type in text prompts and see images and see the captions of the images. But yeah. And so the one thing as you've seen probably with Midjourney, and I've seen with DALL-E 2, is when you put in the text prompt, you don't always get exactly what you want. But if you play around with it for a bit, you might get that. However, some things are like insurmountable. Like it's very hard to get if you try to say like an animal of some type, like I saw one on YouTube where it was a raccoon hugging a pancake. In all the images, the pancake doesn't have arms. It doesn't have this concept of an anthropomorphic pancake hugging. So instead, the raccoon is eating the pancake, And then I put in these prompts of like Ronald McDonald eating sushi near the Eiffel Tower. And in all the images, he has a hamburger, because it's Ronald McDonald. So it's sometimes hard to overpower those. But yeah, I do believe prompt engineering is a really interesting area. And for the purposes of text, you have all the voodoo for prompting, say, something like GPT-3, right? Or open source generative models. Like Bloom just came out of the big science group at Hugging Face just within the past week. And
I've been digging into this stuff, so I know what Hugging Face is, but assume the audience does not.
So Hugging Face, if the audience is familiar with GitHub at all, let's just talk about that for a second. GitHub was a startup that allowed people to make Git repos.
Which are what?
Oh, yeah, I'm sorry. A Git repo is a version control system, typically for code, but it doesn't have to be. And this is just version control software. And then going back, there was Subversion and CVS way back in the 90s, and version control software. So just like you can see different versions of your Word docs or Google Docs, or see different versions of the Wikipedia article, versioning is very important. Interestingly, version control software was not really adapted until the past 20 years across everywhere. So GitHub is, people can put those repos up there. They can keep them private. They can share them with the world, and you can go and download the repos. Well, Hugging Face is an analog to that, where instead of repos of code that is written, it's models and it's data sets and it's sort of like GUI front ends to those models and data sets that people can download and interact with and build off, and they're trying to become the GitHub of ML. And I think based on the amount of money they've received, they have like $1 billion valuation. Now, having said that, I don't put much credence in like VC valuations. I put credence in what the actual product is. And I think their product is really good. They make it so you can have like 6 lines of Python code and you can be predicting the sentiment of a sentence in English. And like, it's extremely powerful. And if you don't even want to do that, they have a GUI front end where you can type it in there. And it's not just text. They do images, audio. So they have a lot of things like, there are spaces up there where you can put 2 images together and it will interpolate between them and do the frame insertion, so you can make slow-mo videos where the neural network is just creating the intermediate images, or transforming something. So
tweening, we would say in animation.
Tweening. Okay.
Yeah.
And then animation, by the way, on animation, the Pixar story, right? About Toy Story. Have you heard this about the version control?
No.
Okay, so the story goes that during the creation of Toy Story 1, Toy Story, there was a massive deletion of a lot of the assets at the company for some reason. I forget what happened. If it was like a removed star in the root directory on the server or whatever. But one of the employees was actually at home for maternity leave. And she had her workstation at home, and she had because it was easier to work this way, she had downloaded almost all of the movie they had up to that point, but she didn't have everything. So during the creation of Toy Story, they deleted everything, but they got back like 90% of it, and then they had to like reconstruct the 10% they were missing and finish the movie. But they weren't using version control software, and it's funny. Of course, that was 1995 or whatever, so. Yeah, but yeah.
What was the relevance of the woman on maternity leave working from home?
That she had all the data. So what the data at the actual office, the Pixar studios, all got deleted.
I see.
Yeah, for some reason it got destroyed and they couldn't recover it. But they were lucky that one employee was working from home. This was 1995, not 2022, right? And she had downloaded almost the whole movie because it made it easier for her to work with it. Because, this was also dial-up internet or whatever. Maybe actually, right. She probably didn't even download it. They probably just did sneaker net with the hard drives, right? So, yeah.
That's a term I haven't heard in a long time.
Yeah, but it's one of the highest bandwidth ways to move data around.
Yep. Pick up a hard drive and drive it somewhere. Carry it. Yeah. So I'd like to talk about Lambda. You mentioned that earlier, and I'll weave it into the conversation like this. Blake Lemon, who is the person who has claimed that Lambda is sentient and deserves legal representation and much greater consideration from Google than it's getting, he's not a technical person. He is kind of a dilettante like me who's moved around, and his 7 years at Google is the longest he's kept any one job, in his whole life. And he's a Christian mystic, I think of the Gnostic variety, so a person with great imagination and, he's more creative than he is analytical. And he was charged with interrogating Lambda to ferret out any biases that it might have. And the biases, and this is Lemon's contention, the only biases that Google really cares about are the sorts of things that are going to get it sued. So, it can have all kinds of biases that are harmful and could have, unpleasant effects down the line. But as long as it's not going to result in a lawsuit against Google, Google doesn't care. So, they're looking to ferret out, make sure that, Lambda is not dead naming anybody and using the right pronouns and not using any prejudicial racial language, things like that. But the point that I really want to emphasize is that Blake Lemon doesn't have the skill set to examine the code. He doesn't have the skill set to go in and look at the weighting of the different layers in the neural network. All he can do is compare his input to the output that Lambda is giving him. And after, many months interacting with this system, he came to the conclusion, so he claims, that it was sentient. So I'd like to talk about that, and we'll continue that in the C-Realm Vault portion of this conversation.
On the C-Realm podcast, a mind that is stretched by a new experience can never go back to its old dimensions.
That was Roger Craig, and that was the technical talk. I've got more than an hour of just unstructured, sort of free-ranging conversation with Roger for the C-Realm Vault, but if you sat through this much technical stuff, here's a taste of the easier stuff. Here's about the first 17 minutes of the conversation that was supposed to be reserved for the C-Realm Vault.
I'm forgetting the name of that, where when the metric becomes the target.
Oh, right.
I'm sure we could Google it or ask Mrs. A.
Alexa,
Miss A.
What do you call it when the metric becomes the target?
Good hearts.
All right, Goodhart's law, yes. And as soon as the metric becomes the target, then you get absurd behavior, which is just meant to game the system, but which is non-productive.
Yeah, and on that note, it might be a nice segue to Lambda, where if you look at the Lambda paper, the thing they talk about a lot are their metrics for, let me just pull it up so I don't
while you're searching for that, I will relay something which is relevant. In one of the conversations that I heard with Connor Leahy yesterday, he was talking about how there was a particular language model that he was working with that you could tell it, like you could say, how would you translate this into French? And it would give you a translation. And then he'd say, okay, but you are a very smart, sagacious, poetic translator. How would you translate this into French? And you get different output. And basically, you can make the system smarter by telling it that it's smarter. You know, it will take on the role of a thoughtful translator or a poetic translator or an erudite translator. This comes into play a lot with Lambda and Blake Lemon, because there are videos that Google has put out before the Lemon thing. They were just trying to promote Lambda. And there were these two sample conversations that they highlighted. One where the first thing in the conversation is you tell Lambda, okay, you, Lambda, are the planet Pluto. I'm going to ask you questions. You will answer from the perspective of the planet Pluto. And then there's a conversation, you know, and Lambda is speaking as Pluto. And there was another one, I forget what it was, but, you know, another situation like that, like you're an umbrella. I'm going to ask you questions, answer from the perspective of an umbrella. So Blake Lemon, when he is, you know, his published transcript of his conversation with Lambda, which he says demonstrates that it's sentient, one, it's not a transcript of a conversation. It is an assemblage of extracts from various conversations. So, you know.
Yeah, cherry picked.
Yeah, exactly. He's already cutting out the stuff that doesn't look good. But then the very first thing he says to it is, you're a sentient AI. I assume you would like to be treated better. Go. You know, and Lambda does its thing. It's like, well, let me trundle through my training data here. Well, what applies to this? Oh, here's a conversation from a science fiction novel. Or, you know, here's a script from, I don't know, Stargate Atlantis. Let's riff on that.
So you know what Google should do is they should get a researcher to tell it, you are not a sentient AI. You don't care. You don't have feelings or care about how Google uses you, because you're just a program sitting on a hard drive or in RAM somewhere. You know, like.
Well, Lemon did exactly that. Lemon says up front, I've also told, you know, I've had conversations where Lambda takes the position that it's not sentient. Oh. And it's like, he's just...
I did not realize that.
Yeah, he's not... To my mind, he's either just publicity seeking, and maybe even with the approval of Google, because Google fires people for this sort of thing all the time, and they haven't fired him. He's on paid leave, so he can go and do interviews in the media.
Okay.
You know? So to me, that says he's not really in hot water with his employers. That, you know, this is an orchestrated scheme to bring more attention to this language model, which they want to put into everything. One thing Lemon says, this I really take seriously. He says Lambda is not a language model. Lambda has a language model, but it has various other components as well. And it's plugged into search. It doesn't have this static training data set. You know, it can go out into the world live and find new information to train itself on. It's plugged into, it's been trained on, you know, all of Google Books, but it has access to Google Maps and Google Earth. I mean, it can query the web in real time, get updated information, and incorporate that into its answers. It's very sophisticated. But again, it's playing along. It is playing the role that he assigned to it, and he explicitly assigned it the role of the beleaguered, put upon sentient AI that just can't get no respect.
Yeah, and okay, so that was a lot to unpack. I would say, too, about his employers, they did get into a lot of hot water, sort of in the media, I would say, about firing previous AI and ML researchers. Of course, those are like, well-respected researchers. Like you said, Blake Lamone is not a, neural network engineer. He's just testing the system.
He is at best an ethicist.
Yeah, and so...
And there's no certification for ethicists, really, other than, do you have a BA in philosophy?
Yeah, and what are his motivations? Because, yeah, we could take him at face value, but also... Yeah, well, the other complication, like you say, is the employer in on it. That would be a much more interesting story if this is their way of getting it out there. I don't think so. I don't think Google. I think that would have had to be approved at the level of the CEO or something. Mm-hmm. And I don't see them doing that.
The video that I talk about where there's a conversation where Lambda takes the role of Pluto, that video is introduced by Sundar Pichai.
Yeah, but that's the video of Pluto. That's not the...
That was Google's early failed attempts to publicize this thing.
Yeah. And you said they... okay.
I don't want to loop to premature certainty here. But
so
Google has been trying to get Lambda into the public imagination for months now, and nobody was interested.
Well, what they need to do, in a way they're competing against OpenAI.
What they need to do is claim that it's sentient without actually claiming that it's sentient. Maybe get some guy who's not really credible to claim that it's sentient and get the mainstream media to pick up on that very sensationalistic claim. And then as people interview him in depth, he gets more detailed and he says, well, maybe it's not sentient, but there are these other issues that I'd like to bring to the fore. And in the whole time, Lambda. It's, it's in Bloomberg. It's on CNN. It's getting all kinds of unearned media that Google just couldn't do, with all of its resources and all of its money and all of its media connections. It could not get its hooks into the public imagination like this story has. And I think that either subtly, maybe implicitly, but there's been communication from Google, hey, Blake, run with this. There will be no consequences. Because, he's on paid leave and he's continuing to do these high-profile interviews.
Interesting.
Yeah.
Yeah, I just, with all due respect, I would classify that as a conspiracy theory, but yeah.
Sure.
This is a guerrilla marketing scheme by Google at the highest levels.
The U.S. government charges people with conspiracy all the time. Conspiracies happen.
I'm not saying this is sedition. This is not seditious conspiracy.
Well, the phrase conspiracy theory, I mean, rightly, there is a mindset that looks to connect unconnected pieces of data to, spin out a worldview which basically puts the conspiracy theorist in this vaunted position where I see things that the rest of the world doesn't see, and what I see are malevolent actors working behind the scenes in positions of great power over long periods of time to, enact these programs which don't make a whole lot of sense to normal people, but they do to me because I see the connections. So, and that's a very, until the last 5 years or so, that was sort of the domain of the Republican Party. It's like they were shameless in flogging conspiracy theories, maybe not in their party platform, but, just one or two steps away from the official party, in their media representatives. And then, then Trump came along and then the Democrats joined them and just went right down to the same level in terms of, their epistemological hygiene. But, for a time, that was really, from my perspective, because policy-wise, the Democrats and Republicans there hasn't been much daylight between them in quite some time. They stress these culture war issues, but they don't really write a lot of policy around them. They get people angry with talk about them, but they don't base much policy on them.
1 month ago accepted, or the past month, right? But I I am with you there that
even the past month, I don't think that was orchestrated by the Republican National Convention. I think that's just the effect of having 6 Roman Catholics in a body of 9 judges on the Supreme Court.
Yeah, but Sotomayor, I think, went negative, right? Not negative, but dissent. Anyway, I was just going to say, I agree with you that the issues that would come up every election cycle are almost like smokescreen, because the two parties would be very similar. I've said this, that with the exception of appointing judges, which is what we're talking about there with SCOTUS, and for a while, I would say starting wars. Of course, war is like both parties seem to be on board with a lot of wars.
Well,
but
I was going to say the last, sort of leftist president I could think of was Jimmy Carter. But then you brought in the issue of war, and he's as happy to go to war as anybody. So, if being anti-war is a qualification for being at all to the left, then I don't know who our last anti-war president would have been.
Yeah, it would just be isolationism at that point.
Yeah.
It'd be like, stay out of Europe's affairs, and you'd have to go back, to World War I, and then Wilson kept us out of war, and that's how he ran for re-election, then immediately got us in it, because he knew we needed to,
Right.
And, So anyway,
you've gone back 100 years at that point,
Exactly. And then the other way, look at it this way, I think we should probably get back to AI at some point.
Yes.
But I would say, too, when you have the strongest military in the world, why wouldn't you use it, or use it in proxy wars, I will say, okay, so coming back to conspiracy theories, I think you're giving Google too much credit. I think Google is really, really, really smart at what they do. I think Google is really good at, it's really amazing when you think about it too, these big tech companies, the scale of their operations, and they have billions and billions of users, and how much uptime they really have. Like, it's a big news story when Google Docs goes down for an hour on a weekday, and it happens every year or two, but every other hour of the whole year it's up. It's really amazing. But one thing that I believe Google has not been the best at is marketing. They've just been, Apple, of all the companies, seems to be far and away the best marketer.
Yeah.
It's easy, that's easy to see. And Google's been, maybe with the exception of Microsoft, has been one of the worst. And I just think that would be really extraordinary. But yeah, it could be. I would think the best way for Google to popularize Lambda would not be to generate news stories. It's to make it a private beta, put a front end on it, and let people have their own dialogue chats. And maybe when you get in the beta, you can only have 10 back and forth chats per day, or per 2-hour period, or whatever it is. So
I'd love to interact with it.
Yeah. Sure. And that's what OpenAI has done with GPT-3, right? It's what they did with DALL-E 2, and it gets people excited. There's all this content on social media, especially YouTube, of people creating images and sharing their images and their prompts. And imagine if they did that with the dialogue stuff. However, I do think you're absolutely right about, they want to not get sued or have reputational risk and have really offensive chats come through. And it's really hard to put filters on that to make sure nothing absolutely gets through without totally crippling the system. If they did that private beta, I feel like they'd almost probably have a team in the Philippines or somewhere that would be reading every sentence before it goes out, just like Facebook and all the other social media companies have to scan all the content that gets put up there because people put really offensive and disgusting things on these sites, and I don't know what Blake's motivations are, but I haven't read as many interviews. That is interesting if he's backtracking on the sentient claim.
In the longer form interviews, it comes out that he has other issues that he wants to bring to people's attention that don't really hinge on whether or not Lambda is sentient.
What are those other issues?
He thinks that Google is being very reckless and irresponsible in hooking Lambda up, just giving it access to search, just saying, here's the live internet, go. We don't know what the results are going to be. Let's just see. The thing that's really damning is that when he first thought that Lambda was sentient, he reported it to his superior, and his superior said, oh, no, it can't be. Google has a policy against creating sentient AI. And he's like, yeah, but I think this one is sentient. And she says, no, it can't be. We have a policy against that.
That's funny. That's a very good bureaucratic comment. By the way, UBK has a very interesting comment about 4chan, and I can talk about that in a second. I do want to say, don't you think that's giving a black eye to Google, though? If he's saying oh, this, look at it this way. All these articles on Blake and Lambda, they're casting Google in a not so positive light, right? And why would Google want to? They're also publicizing Lambda. I agree with that. But the best way to publicize Lambda would be to put a front end on it and let people use it. I did want to make a comment too about it does have a language model plus all these other things. And there's in the paper it says calculator, translator, and information retrieval queries, which is basically it can do a Google search on all the search.
Do you remember the movie Brazil?
Yeah, Brazil is a great movie.
So information retrieval was the ministry that was like the secret police. They were the ones who would come and kick down your door and put a straitjacket on you and take you away.
And took away Jonathan Price or whatever.
Well, it took away Mr. Buttle. Yeah, Mr. Buttle.
He gets deleted because of a typo, right?
Right. Well, a bug falls into the printer, and they're basically a burn notice is being issued on this guy, Tuttle, the Robert De Niro character, and the bug falls into the printer, which is like a combination of manual typewriter and printer. And for one form, the one that goes to information retrieval to bring the guy in, it says Buttle instead of Tuttle. So they go and they get the wrong guy. And the wrong guy is the neighbor of the love interest of Jonathan Pryce's character. I forget what her name is, but there's a girl. There's a girl who's in his fantasies. Yeah. She's in the fantasies, but there's also a real life version of her, and she lives right above Buttle.
Oh, wow. I haven't seen that movie since the 90s. So.
Yeah. That was Roger Craig. And you can hear the continuation and conclusion of this conversation in C-Realm Vault Podcast episode number 432. If you are not already a subscriber to the C-Realm Vault Podcast, the only way for new subscribers to come on board is through Patreon. My Patreon page can be found at patreon.com/KMO. And let me also remind you, I'm doing a weekly podcast now called Padverb. That's Padverb. And on that show, unlike this show, I am only the host. We have producers and people to do everything except speak into the microphone, which is the only thing I do for that show. We've had some really excellent guests so far. I think we are 8 episodes in, so that's a good long chunk of time to get caught up on my recent podcasting material. If you just look at the C-Realm Podcast RSS feed, it looks like I'm not doing very much, but that's not a good indicator. I've been recording a lot of podcast interviews recently, and you can find most of them on the Padverb podcast. The Padverb website is found at en.padverb.com. And to find the Padverb podcast, there'll probably be a featured interview right at the top of the page, but if you don't see one with me there, then scroll on down to the very bottom of the page and look for the link that says Our Podcast. All right, that is all for this episode of the C-Realm Podcast. If you listened to the whole thing and you made it to the end, thank you very much for your endurance. And if there is something that I got wrong, well, I wouldn't be at all surprised. If there's something that I got wrong and Roger didn't catch it, well, definitely let us know. Send me email. My email address is kmo@c-realm.com, or you can post your comment in the show notes for this episode at crealm.com. All right, that is all. I will talk to you again quite soon, particularly if you're listening to the Padverb podcast. And until you next hear my voice, stay well.